All right, guys. So we're going to try a lesson on the metric unit with some scientific notation, but we're going to start with this do now. What's the capacity in milliliters of a 1.5 liter beaker? All right, so for that first one, right in yellow here, 1.5 liter beaker. So our base unit is liters, and we're looking to convert to milliliters. Now I know that to go from liters to milliliters, you're talking about a factor of 1,000. If you want to go look at the steps to double check me, you can, but you will pretty much get really good at memorizing these. So it's a factor of 1,000. The question becomes, are you multiplying or dividing by 1,000? Well, in this case, when you're going from a big unit like liters, trying to convert it to a smaller unit like milliliters, you're going to have to multiply by 1,000. So 1.5 times 1,000 will give you your answer of 1,500 milliliters. All right. All right, so next one. Take a minute, try the second one. An object is measured to be 0.01 meters long. How many millimeters long is it? All right, so again, you have the base unit. This time it's meters, measuring length. And we're going to go from the base unit of meters to millimeters. So again, we're going from a big unit down to a smaller unit. You again have to multiply. And again, there's 1,000 units difference between the base unit meters and millimeters. So you're going to multiply by 1,000. 2, 3. And your answer should be 10. 10 millimeters. Okay. All right, so your answer here is 10 millimeters because 0.01 times 1,000 is 10. All right, moving on. Our objective today, as I sort of hinted towards, will be to convert between metric units by using scientific notation as necessary. So we're going to use scientific notation. I'm operating under the idea that you guys have used it before, but this is maybe a review for some people, but maybe some people are not very good at it, not experienced with it, and maybe this is the first time you're going to go through it in detail. Either way, you'll need to get more comfortable dealing with scientific notation. So here we go. A little food for thought. You generally know how big a cell is, and you know there are 150 trillion atoms in a single cell. I believe I mentioned that in my first video, Edpuzzle video to you guys. So now think about it. Could you measure an atom in meters? Why or why not? All right, so there's no totally right answer for this. Of course, I could give you the length of a cell in meters, the length of an atom in meters. But could you take a meter stick? Could you take a meter stick out and measure how big an atom is? Of course not, because atoms are so small, you wouldn't be able to actually measure it with something that big. But you could report its distance, its length in meters if you wanted to. So we're going to talk about how to sort of negotiate that. How do we sort of measure things differently? How do we report measurements in different units, especially for things that are really big and things that are really, really small? So what we have in our reference table, on table C, the front page of our reference table, you see this, and it talks about some of the metric prefixes that you'll need to use for this class. So take a minute. What does this table mean? What information does it tell you? How might you use it? Why might it be tricky or difficult to use? All right, so let's break this down for a minute. Let's get into the nitty-gritty of scientific notation. How would you write out 1 times 10 to the third? How would you write out 1 times 10 to the negative third? So let's talk about that first one. What does this really mean? Let's break that down. All right, so it's 1 times 10 to the third. Sometimes it helps if you actually do what it says. And some students, when they have their scientific calculators, you actually type it in, like 1 multiplication sign, 10, caret 3. You just type it all out, and you actually do get the right answer because you can sort of break it down that way. Using a little order of operations, what you're essentially saying is 1 times the quantity of 10 cubed. All right, so 10 cubed is nothing more complicated than 10 times 10 times 10. So you can sort of say this all equals 1 times the quantity of 10 times 10 times 10. Sorry guys, I'm not very proficient at writing with this little pen, but I try. So 1 times the quantity of 10 times 10 times 10, 10 to the third. And 10 times 10 is 100, times 10 again is 1,000. So 1 times 1,000 is 1,000. So what you see here is a really fancy way of writing 1,000. And when you break it down like that, it maybe might not be so intimidating. All right, so now that gets us to the second one. What does that one mean? All right, so this gets a little trickier, and I don't mean to like confuse you guys, but the negative exponent means it's going to be like the reciprocal. It's going to be the 1 over 10 times 10 times 10. So it makes it like, it flips it around a little bit. So it's still something similar. It means 1 times the quantity of 1 over 10 times 10 times 10. Okay, and that is going to equal, it sounds similar, but it's not. Instead of 1,000, like it is up here, it's going to be 1,000th, which means it's going to be 0.001. So it's 0.001, 1,000th. So these two are very similar. The only thing different is that little negative exponent. But it still shows you the very basics of how to sort of break down scientific notation and sort of stretch it out so that you can answer it correctly. So now you start to see how this works. Let's start to look at a few specific questions that are ones like you might see in this class. All right, so all it does is allows you to use factors of 10, so it allows you to condense numbers with many digits into smaller, easier ways. So take a minute and look at these two. All right, you're looking at 3.5, well, let me say it this way, 3 billion, 500 million, that's your answer, right? 3,500,000,000 as a number. Now, if we break that down and we put it into scientific notation, instead of writing 3, 5, and then all these zeros, you can condense that all to say 3.5 times 10 to the 9th. Same thing over here. So this is obviously a very big number. This works the same for smaller numbers. So if you have a really, really small number, instead of counting all these zeros, you can write this as 7.9 times 10 to the negative 8th. So I want to talk about really quickly where these exponents come from. And then we're going to try some questions. This is the last step here. So how do you get this scientific notation from this number? So here's the deal. Right now, when you write 3,500,000,000, there's a decimal point right here. So there's my decimal point. And let's say it was like 3,500,000,000.5, you would put a little 5 in here, right? But there is no 5, so the decimal point is right there. It's right there. So the question becomes is, how do I get this out of that? Well, you have to move the decimal point to its position over here. How many places? 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you want to move the decimal point to where it is, to where it would be for scientific notation, it's 9 places, which is where that 9 comes from. Now, a couple of things that confuse some students. It's unnatural to write something like this. Like you wouldn't write this like 0.35 times 10 to the 10th. Although mathematically it means the same thing, you always want to have this leading number to be between 0 and 10. You don't want it to be, you want it to be between 1 and 10. You'd prefer it not to be less than 1, and obviously you wouldn't want it more than 10. Similarly, you wouldn't say 35 times 10 to the 8th. That's also, I don't know any other way to put it other than it's weird and not conventional, but you always want the first number in scientific notation to be between 1 and 10. So it's like 3.5 or 4.7 or or 2.9. You don't want it to be like 29 times 10 to the third. You always want it to be some number between 1 and 10. So here it is, 3.5 times 10 to the ninth. That is my correct answer. Same thing down here. So for this one, you have to move it over enough decimal places so that you get a number between 1 and 10. So I'm all the way over here now. Here's my decimal, but we have to move it to the right. 1, 2, 3, 4, 5, 6, 7. 7 puts it there. That would be 0.79 times 10 to the negative 7. So that's not good enough. We got to go one more, and then now we're in between. So when we're in between the 7 and the 9, it becomes 7.9. And 7.9 is between 1 and 10. Check. So we have 7.9, and we had to move over to the right 8 decimal points, which means it's a negative 8. When you move the decimal point to the right, it goes negative. When you move the decimal point to the left, it goes positive. So that is the basics of scientific notation. All right? So these are the units you'll be expected to look at, so you might want to have them handy, or you can just rewind in the Edpuzzle video. Otherwise, you can just get your reference table out on Google Classroom. We're going to do 3 questions and try an exit slip question, and you guys are done. All right, so go ahead. Give this one a shot. All right, so now we have scientific notation. You have the conversions that are also expressed in scientific notation. So you have to sort of juggle all that together. Here we go. So don't freak out. You're going from kilometers, which is a big unit, big, like, you measure miles with it, to meters, which is a smaller unit. So you're going from a big unit to a smaller unit. You have to multiply. So this will be a multiplying question. And you have to go from kilometers to the base unit. Those are 1,000 units apart. So you're going to multiply by 1,000. So you're going to take this number that's already in scientific notation, and you're going to multiply it by 1,000. Okay? So your final answer, and you could write out the whole thing, but I'm going to see if you can express it in scientific notation. See if you can express it in scientific notation. All right, so 3.21 times 10 to the fourth, all multiplied by 1,000. I can do it in my head because I've gotten good at this. It's going to be 3.21 times 10 to the seventh. And you'll start to learn some of these little tricks with scientific notation. Is that 1,000 can be written as 1 times 10 to the third. And when you multiply exponents, when you multiply numbers with exponents, you just add them up. So 4 and 3 gives me the 7. If you don't believe me, you can plug this in your calculator and you can prove it to yourself. That's your final answer. So there would be 3.21 times 10 to the seventh meters. I'll put my unit there. In 3.21 times 10 to the fourth kilometers. And now pause for a minute and think about it. Does this make sense? Kilometers are very big. Meters are smaller. So if you're going to go from kilometers to meters, the number that you have in meters should be bigger. And this is 3.21 times 10 to the seventh is bigger than 3.21 times 10 to the fourth because you have more of the smaller unit in that same distance. So to me, that makes sense. Let's try 2 more. How many liters are there in 5.75 times 10 to the fifth milliliters? All right, so I'm going to go from milliliters to liters. In this case, I'm going from a smaller unit like milliliters to liters. So I will be dividing. It's a dividing question. And the factor conversion between milliliters and liters is 1,000. So you have to divide by 1,000. So what happens when you take this number and you divide it by 1,000, or you divide it by 1 times 10 to the third? So what would you get? You would get 5.75 times 10 to the second. And if you wanted to write it out differently, you could just say 575 liters. Both of those numbers are the same. They're both correct answers. Okay? One more. All right, picometers. Picometers is something that we'll find in your reference table. If you look at the last column of your reference table on page 9 or 10, it'll say atomic radius in PM, and PM are picometers. So picometers measures the radii of small atoms. So you can tell it's a tiny, 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 tiny unit. So let's answer this question. How many picometers are in 5.6 times 10 to the negative 10th meters? All right, here we go. So we have 5.6 times 10 to the negative 10th meters. You're going to have to use the conversion for picometers. Let's sneak back here. 10 to the negative 12. So you have 10 to the negative 12. So what you're going to end up doing is take this number, and you have to ask yourself, am I multiplying or dividing by 10 to the negative 12th? Well, picometers are super tiny. Meters are bigger. So you're going from a big unit like meters to picometers, which are tiny. So you're going to multiply. So you have to multiply this crazy number times another crazy number, 1 times 10 to the 12th. So you're going to multiply that number times 1 times 10 to the 12th. The answer should simply be, put me on the spot now, 560. Do I have that right? 560 picometers. Let me double check that really quick. All right, so it is 560 picometers. All right. All right. So look, guys, I know we're probably cruising through this for some of you guys. Some of you guys think it's too easy. Some of you guys are probably really confused. It's just an introductory assessment, introductory assignment to get you guys used to looking at metric conversions that involve scientific notation. So the goal was to convert between metric units by using scientific notation as necessary. Here is your exit slip. A beryllium atom has a radius of 99 picometers. How many meters is this? All right, now we're sort of doing the reverse of the last question. We're going from a very, 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 very small unit like picometers into a bigger unit of meters. So when you go from a small unit to a big unit, you have to divide. So whatever it is, we're going to have to divide. So we're going to divide, and the factor is 1 times 10 to the 12th. Oops. So we have to take this number, 99 picometers, and we have to divide it by 1 times 10 to the 12th. So your final answer is going to be 9.9 times 10 to the negative 11th meters. And that's your final answer. All right. Of course, you could write this out like it'd be 0.0000000 whatever 0.99 meters, or you can write it like this, which is much easier for me to check if the answer is right, because all I have to look at is a small decimal and the right exponent. So this is how you use scientific notation. Our next lesson on the metric system that'll probably conclude our little 3 lessons will be about significant digits, and then that should do it. All right, guys, that's it.